The internal elements of a valve are collectively referred to as valve trim. The trim typically includes a disc, a seat, a stem, and, when applicable, a sleeve needed to guide the stem. The performance of a valve is determined by the disc and seat interface and the relation of the disc position to the seat. Because of the trim, basic motions and flow control are possible. There are actually two motion trim designs: rotational and linear. Take a look at the following 3D animation. In rotational motion trim designs, the disc or the ball slides closely past the seat to produce a change in flow opening. In linear motion trim designs, as depicted in this video, the disc lifts perpendicularly away from the seat so that an annular orifice appears. In the next couple of videos, we'll see each trim element in detail. We start with the disc and the seat. For a valve having a bonnet, the disc is the third primary principal pressure boundary. The disc provides the capability for permitting and prohibiting the flow of fluid. When the disc is closed, full system pressure is applied across the disc if the outlet side is depressurized. For this reason, the disc is a pressure-retaining part. Discs are typically forged, and in some designs, they are hard-surfaced to provide good wear characteristics. A fine surface finish of the seating area of a disc is necessary for good sealing when the valve is closed. Most valves are named in part according to the design of their discs. This will be covered in details further ahead. The seat that you can see here provides the seating surface for the disc. In some designs, the body is machined to serve as the seating surface, and seal rings are not used. This is the case of our example here. However, in other designs, seal rings are threaded or welded to the body to provide the seating surface. To improve the wear resistance of the seal rings, the surface is often hard-faced by welding and then machining the contact surface of the seal ring. A fine surface finish of the seating area is necessary for good sealing when the valve is closed. Now, keep in mind, seal rings are not usually considered pressure boundary parts because the body of the valve has sufficient wall thickness to withstand design pressure without relying upon the thickness of the seal rings.